Okay, today we're going to be excuse me, taking what we've been learning previously, and we're going to look at expressions of the form a sin x plus b cos x, and we're going to write them in the form of an expression r sin x plus or minus a or alpha. So let's look at this more closely. So let's see if we can take a sine, I'm going to call it theta, oops, that's terrible, theta plus b cosine theta, and we can replace it by an expression r sine theta plus alpha. So let's look how we would do that. Let's look at first well, we're assuming firstly that r is going to be greater than 0 and that alpha is between 0 and 90 degrees. So let's look at r sine theta plus alpha. So we can, from what we've been doing, this is going to be r sine theta cosine alpha plus cosine theta sine alpha. Therefore, a sine theta plus b cosine theta equals r sine theta cosine alpha plus r cosine theta sine alpha. Now what we can do is just equate coefficients. So first we're going to equate coefficients of sine theta. So this part here and this part here. So that would mean the a here would have to be equal to sorry, r cosine theta. Now we're going to equate the coefficients of the cosine theta. So this part here. So that'll give us b equal to, so there's a cosine. Oh, I've done this wrong way around. There's sine theta. So that's r, sorry. There's sine theta here, sine theta, so r cosine alpha. And then the b cosine theta, there's cosine theta here. So it's going to be r sine alpha. Hope that makes sense. Sorry, I wasn't reading it properly. So we're, just to make that clear because I messed it up, we've got this expression a sine theta plus b cosine theta, and we want it in this form. We've taken this form and we've applied our compound angle formula and got this. And now we're just equating coefficients. So a, for these to be equal, a here must be equal to the r cosine alpha, and the b must be equal to the r sine alpha. Now, I'm going to call this equation 1, and we're going to call this equation 2. Now, if we take equation 2 and divide it by equation 1, we have sine alpha over cosine alpha, and that must equal b over a, which by implication tan alpha must be equal to b over a, just from the previous identities that we've been learning about. now we're going to look at now we're going to use our identity of cosine squared alpha plus sine squared alpha must be equal to 1 to get the next part of what we're doing. So A is this and B is that. So if we do A squared plus B squared, we have R squared cosine squared alpha plus R squared sine squared alpha, and we now can take that out here, and then we've got cosine alpha plus sine squared alpha, and that must be equal to 1. So R squared must be equal to A squared plus B squared, therefore R must be equal to the square root of A squared plus B squared. Let's write down what we've this in full. So what we've discovered is for A sine theta plus, and we can do it for plus or minus, you can work through the same argument for minus as well. For A minus B cosine theta, and we want to make it equal to R sine theta plus or minus alpha, or if we want A cosine theta plus or minus B sine theta equals R cosine theta minus or plus alpha, then R is going to be equal to the square root of A squared plus B squared, and tan alpha is going to be equal to B over A, and that works for alpha between 0 and 90 degrees. Now this is something that you need to know, and we're going to be if it's a bit complicated, it'll hopefully become clearer once we go through a few examples, and also might become clearer why we would do all this, why would we manipulate the equations in this way. Express 2 sine theta minus 3 cosine theta as R sine theta minus alpha, where R is greater than 0 and alpha is between 0 and 90 degrees. Now, so what we're going to be doing is using what we've just been learning to find the value of R and to find the value of alpha. Then we want to solve 2 sine theta minus 3 cosine theta equal to root 2. So hopefully now you're going to be seeing that by doing this, solving something like this is going to become a whole lot easier. And we're doing that for theta between 0 and 360. So first let's get it into this form. So for 2 sine theta minus 3 cosine theta equal to R sine theta minus alpha, we'll use our compound angle theorem. So R sine theta cosine alpha minus R cosine theta sine alpha. And now we equate our equations just like we did in our general example. So for the sine theta, so for this bit, 2 must be equal to, so where's sine theta, that's sine theta here, so must be equal to r cosine alpha. And for this one here, for the cosine part of it, 3 must be equal to, so there's a cosine theta, r sine alpha. Now remember there's a minus and a minus here, so that's fine. So now we're going to divide this by this. So 2, wrong way around, this by this. 3 divided by 2 will be equal to sine r sine theta over r cosine alpha, which is equal to tan alpha. The r's cancel, and therefore we can just solve this with our inverse tan. So alpha must be equal to 56.31 degrees. Now we know that a squared plus b squared equals r squared. So 2 squared plus 3 squared equals 4. Add 9 is equal to 13. So r must be equal to the square root of 13. So therefore our identity is going to be 2 sine theta minus 3 cosine theta is equal to r, which is root 13, sine theta minus 56.31. Now we are going to solve this equation, but I'm going to write this on another page. So we want 2 sine theta minus 3 cosine theta equal to root 2. So we're going to replace this by our expression r sine theta minus alpha, which was root 13 sine, open bracket, theta minus alpha was 56.31 equal to root 2. We'll divide both sides by root 13, so that's sine theta minus 56.31 is going to be equal to root 2 over root 13. And then we can take the inverse sine to get theta minus 56.31 must be equal to 23.09 degrees. Now, because that is positive, all students trust Cambridge, so it's going to be in this quadrant, so it's going to be in here somewhere, so we'll also get 180 minus 23.09, which gives us 156.91. And now, so we now need to solve for this. So theta will be 23.09 add 56.31, which gives us 79.4 degrees. And likewise on this side, theta will also be 156.91 add 56.31, so it's going to be 213.2 degrees. So I hope that makes sense. Now we can use our expression, let's get another page up. We can use our general r sine theta plus alpha to find the maximum and minimum of an expression. So we know that for sine of alpha plus theta plus alpha must be within the range 1 and minus 1. Therefore, if you multiply this expression by r, it must be between r minus r and r. Hence, for the maximum value of a sine theta plus b cosine theta is a squared plus b squared, the square roots of the value of r, when sine theta plus alpha equals 1, and the minimum is minus a squared plus b squared when sine theta plus alpha equals minus 1. So let's do an example to show this. So firstly, we're going to express 2 cosine theta minus sine theta in the form of r cosine theta plus alpha, again for r greater than 0 and for alpha between 0 and 90. And then we're going to find, the maximum and minimum. So firstly, let's do 2 cosine theta minus sine theta is going to be equal to r cosine theta plus alpha. We expand that out and get r cosine theta cosine alpha minus r sine theta sine alpha, and now we're going to equate coefficients. So the cosine, for cosine theta, we've got 2 is equal to r cosine alpha, and for sine theta, we've got r versus sine theta, so it's going to be 1 is equal to r sine alpha, and then we're going to divide them, so we'll get tan theta must be equal to a half, so alpha must be equal to 26.57. Next part, a squared plus b squared equals r squared, so that gives us 2 squared plus 1 equals r squared. That's going to be 5, so r is going to be the square root of 5. Hence 2 cosine theta minus sine theta is going to be equal to the square root of 5 cosine theta plus 26.57. Now the maximum is going to occur when cosine theta plus 26.57 equals 1. So cosine is equal to 1 at 360. So theta plus 26.57 must equal to 360. And again, we've got our All Students Trust Cambridge. So this is positive. So it's going to be down here. So it's 180 plus, but that's going to take us out of our range. So we're just going to do theta 360, and then that's going to be minus, so it's 333.4. And then similarly for the minimum, cosine theta plus 2657 equals -1, and that is going to give us, for that'll be 180, so it's theta plus 26.57 equals 180, so theta equals 153.4. So that would be the one for this quadrant, 180, and then you minus there to get to there. And then the maximum, so the maximum is going to be square root of 5 when theta is 33.4 degrees, and a minimum of -0.5 when theta equals 153.4 degrees. So I hope that helps.